I am Rajiv Saxena, Associate Professor, Smriti College of Pharmaceutical Education, Indore. In today's video lecture, we'll discuss about the microbiological assay of antibiotics. Microbiological assay is a collection of methods that is used for the qualitative and the quantitative analysis of any substance by the use of the microorganism. We know that, for example, if we are talking about the antibiotics, so antibiotics are the agent that is used for the destruction or killing of the microbes. So suppose if there is some new molecule is available, that we have to claim that it is having the power to kill the microorganism, but before using that molecule in the form of a drug, first we need to test that agent, that chemical, that whether it is having the potential of the destruction of the microorganism or not, or maybe it is behaving like antibiotics or not. Okay, again it is observed, like for example, if you are talking about various plant category, so nowadays many people are doing research in the extract of various categories of the plant, and they are claiming that these extract is having the potential, that they have the power to kill the microorganism and may be benefited in conditions of the infection. Okay, and they are also preparing various categories of the formulation, herbal formulation, by using those plant extract. But before claiming that this particular plant extract or plant is having the property to destroy the microorganism, first the scientific proof have to be provided. So even for that we have to go for the microbiological assay of antibiotics. Now, definition wise we can say that the microbiological assay of antibiotic is based on the study of the inhibition of the bacterial growth by measuring the concentration of the antibiotic to be examined with that of the standard antibiotic. It means here two terms are important. One, which is a test solution or the test material or the test antibiotic that we need to study, and the second one is the standard antibiotic. So in case of the microbiological assay of antibiotic, we need to compare the standard solution with that of the test or the solution which is under investigation. Suppose some new antibiotic is available, maybe we are doing some chemical modification in the already existing antibiotics, then also what we have to do, we have to check the efficiency of that unknown antibiotic or the new antibiotic with that of the standard antibiotic. So by the means of comparing the test and the standard antibiotic, we can easily perform, we can easily compare, we can easily claim that our test solution is having the property which is somewhat similar to that of the standard antibiotics. Now coming to the laboratory procedure of how we can perform the microbiological assay in our laboratory. So for performing the microbiological assay of antibiotic, there are three different preparations that we have to do initially in the laboratory. Preparation number one is the media for the assay. Definitely here what we are doing, we are actually cultivating the microorganism in our laboratory, and we are trying to challenge the microorganism to grow in that culture media in the presence of the antibiotic. Okay, so there are three different things. Number one is a culture media, number two is a microorganism, and number three is a antibiotic. So first our target is to grow the microorganism, and once the microorganism are growing, we are adding the antibiotics. So the challenge for the microorganism is that the culture media is available which is responsible for the growth of the bacteria, but one more molecule that is having the property to inhibit the growth is also available, which is actually your test antibiotic or which is actually your standard antibiotic. So growth parameters are already provided, but that growth is actually taking place in the presence of the antibiotic or any substance which is having the potential to kill the microorganism. So we need to assay that if the growth parameters are available and the microorganism is having the tendency to multiply, but if some inhibitor is available, if some antibiotic is available, or maybe some test solution is available which is having the power to kill the microorganism, so whether in that presence of these inhibitor or these antibiotic, whether your microorganism are growing or not. Okay, so for the growth of the microorganism, we know that the most essential thing that is required is a culture media. So in the first step, we have to go for the preparation of the culture media. So as per Indian Pharmacopoeia, different categories of the complex culture medias are already prescribed. Now the next step is the preparation of the standard and the test solution. So as already discussed in the definition or in the principle of the microbiological assay of antibiotic, what we are doing, we are comparing the test solution of the antibiotic with that of the standard solution. How your test solution is actually behaving as compared to that of the standard antibiotic solution. So in the preparatory phase, again we have to go for the preparation of two different categories of the solution. Number one is a test solution, that is under assay, and number two is a standard antibiotic solution. Now the third thing that we need to prepare in the laboratory before performing the microbiological assay is actually the preparation of the inoculum. Definitely the microorganism that is prescribed for a specific antibiotic need to be cultivated in the laboratory in the form of the inoculum. So if we read the IP, then we'll find that for the different categories of the antibiotic, different microorganisms are already prescribed. Like for example, if you are assaying the oxytetracycline, for example, if you are taking the oxytetracycline as a standard antibiotic, then the inoculum that in which we try to assay that oxytetracycline will be as aureus. So if we look at the standard book or Indian Pharmacopoeia, then we'll find out that for different categories of the antibiotic, different microorganisms are already prescribed. So again, we have to go for the preparation of the inoculum. So these are the three things that we need to first prepare in our laboratory. Number one is the culture media that is used for the assay. Number two is the preparation of the standard solutions and the test solution. We know that what is the difference between the standard solution and the test solution. The standard solutions are those whose efficiency is already evaluated by using microbiological assay. We know that penicillin is a standard antibiotic, tetracycline, oxytetracycline, gentamicin. These are the different examples of the standard antibiotics whose efficiency is already evaluated. And the test solution, that is the unknown solution of which we have to go for the evaluation of the microbiological assay. We want to assay the qualitative and the quantitative part of that particular test solution. Okay, so we need to prepare the standard solution and the test solution. And the third thing that we need to prepare is the inoculum. We know that for different categories of the antibiotic, different categories of the microorganisms are already prescribed. So we have to prepare the inoculum of that particular microorganism. Now coming to the method, assay method. Actually there are two methods which are prescribed. Number one is a method A and number two is method B. Method A is also called as cup and plate method, and method B is actually called as Cervidometric method. Okay, so one by one we discuss what we do in method A and what we have to do in method B. Now coming to the method A, which is called as a cup and plate method. This is a very routine method which is followed in the microbiological laboratory. Even these type of experiments can also be performed in the microbiological syllabus. Also, it is also given in the in your syllabus of B.Pharm third semester that we have to go for the assay of the antibiotic, standard antibiotic. Okay, so in that case we can easily go for the use of the method A. So what we have to do in the method A, as you can see in this diagram, there is the presence of one petri dish. Okay, so we have to keep a sterile petri dish, and second thing what we have to do, we have to prepare the culture media. Okay, but in this case the culture media is not in the form of the broth, it is not liquid, but it is actually the solidified media. So in the culture media we have to go for the addition of the agar that will act as a solidifying agent. Okay, so first we need to prepare the culture media, then we have to autoclave it, because before using it, it should be sterile in nature, and for the sterilization purpose we need to go for the autoclaving of the culture media. Okay, but when you take out the culture media after sterilization from an autoclave, then what you will find that culture media is very hot in nature. Okay, So in that hot condition, we cannot go for the addition of the inoculum, but rather here we have to wait for some time when the temperature drops to around 50 to 55 degree centigrade or 45 to 50 degree centigrade. In that condition, your culture media is having the liquefied consistency and it is having the temperature which is tolerable to the microorganism. So in this condition, we have to go for the addition of the inoculum or the standard culture of given microorganism. Okay. So what we have done, we have prepared the culture media, we have autoclaved it, and when the temperature is suitable, it is around 50 degrees centigrade. In that condition, we have to we have to seed, we have to inoculate the culture microorganism in that culture medium. Then after inoculation, we have to pour that solution in a petri dish and we have to wait for some time. Till that time, the agar gets solidified and you will get a solidified media in a petri dish. So once this media will be solidified, then what we have to do? We have to cast different cavities in that petri dish, in that culture media. Means in the petri dish, the culture media is already available and that culture media is having the solidified form. So that in that solidified form, we have to go for making various cylindrical cavities with the help of some special devices, so that in that cavities we can go for the addition of the test solution as well as the standard solution. It means we have to prepare different petri dish, and in one petri dish we have to go for the addition of the different dilutions of the test solution, and in the another petri dish we have to go for the addition of the different dilutions of the standard antibiotics. So what we have to do, whatever the solutions that we have prepared, like we have prepared different concentrations of the standard solution, different concentrations of the test solution. So one by one we have to go for the addition of these solution inside these cavities. Like for example, if I am preparing 50 microgram concentration, that is the least concentration of the test solution, then 50 first dilution I will put here, then 100 I will put here, 150 I will put here, 200 I will put here, and 250 I will put here. So first we have to go for the preparation of different concentration of the test solution also and different concentrations of the standard solution also, and different dilutions are added into different cavities of the well that we have casted in the petri dish that consists of the solidified agar media. Okay, then we have to keep this petri dish for the incubation for around 24 to 36 hours. Then after that, what will happen? These antibiotic solutions that we have added inside the cavity will start diffusing out of the culture media or the solidified agar media. But what we have already added in this culture media, that we have already added the inoculum, that is the microorganism. So again three things are available here. Number one is a culture media that favors the growth of the microorganism. The microorganism itself are available in this media because that we have already seeded or inoculated in the culture media. So two things are favorable. The culture media is available and even the microorganism are available. But the third thing, that is what? That is the antibiotic that can inhibit the growth of the microorganism. But what will happen when the antibiotic solution will start diffusing in the culture media, so the region till which the culture media will be, till the solution of the test solution or the standard solution will be diffuses, then what will happen? Till that area, you will find that no growth is observed. Suppose if your test solution is having the property to inhibit the growth of the microorganism, so till that area where it has been diffused in the culture media, you will find that in that area no growth of the microorganism is available, and that result in the formation of ZOI. ZOI is zone of inhibition. Okay, we know that the standard antibiotic is already tested. So what should be the result of the standard antibiotic? In the standard antibiotic, we will find that definitely the zone of inhibition will be generated because it is already been tested. Okay, so what we have to do, we have to measure the zone of inhibition of the test solution also and as that of the standard solution also. Maybe if your test solution is not having the tendency of inhibition of the growth of the microorganism, then what you will find that in that case no zone of inhibition is available. But if your test solution, if your plant extract, if your new antibiotic, if your modified antibiotic, it is having the property to kill the microorganism, definitely you will find that the zone of inhibition is formed. Okay, so what we have to do, we have to, by using the standard antibiotic, for example this is the plate of the standard antibiotic, so definitely the proportion in the zone of inhibition and the concentration of the antibiotic will definitely be proportional. So by using that concentration of the standard antibiotic and zone of inhibition which is observed of the standard antibiotic, first we have to go for the preparation of the standard curve. In the x-axis we'll keep the concentration of the antibiotic, whereas in the y-axis we'll keep the zone of inhibition. We know that the standard antibiotic is already been tested, so definitely there is a direct proportional type of relationship exists between the concentration and the zone of inhibition. So by using that concentration and zone of inhibition correlationship, will create a standard plot. Okay, so this is actually the standard plot or the standard line which is observed because of plotting a graph between the concentration in units per ml versus the zone of inhibition in millimeter by using the standard antibiotic. But we know that in the test antibiotic solution, suppose if we get the zone of inhibition, then what we have to do? We have to measure the zone of inhibition by definitely by using the scale. So that zone of inhibition reading of the test solution will be in the millimeters. Okay, so we have to put that whatever the reading that we have observed, we have put into the y-axis, and just by extrapolating the graph, we can get the concentration in the x-axis of the test solution. So we can easily correlate here that at this particular concentration or at this particular concentration of the test antibiotic, your results are available. It means your test solution is having the capability to kill the microorganism, and that property is comparable with that of the standard antibiotic. So by using this particular graph between the concentration on the x-axis and zone of inhibition on the y-axis, first we have to plot the graph by using the standard antibiotic. We get the standard plot, and by using that standard plot, what we have to do, we have to again measure the zone of inhibition of the test solution, and whatever the measurement is available in millimeter, we have to put in the y-axis, and by extrapolating the graph that will definitely touch at the point of the standard line, then we have to extrapolate the graph on the x-axis, and from that graph we can calculate the concentration of the test antibiotic. So this is how we can go for performance of the microbiological assay of antibiotic by use of the method A. But one more method is also available which is prescribed in Indian pharmacopoeia, that is method B. And what is the name of the method B? Method B is a turbidometric method. Okay, so by using this turbidometric method also we can go for the calculation of the antibiotic. We can easily go for the microbiological assay of antibiotics. So there is one basic difference that exists between method A and method B. In case of method A, we have prepared the culture media, solidified culture media by the addition of the agar, and we have poured that culture media in a petri dish. But that type of thing has not to be done in case of method B, but rather in case of method B, we have to go for the preparation of the culture broth. Okay, so different culture broths we have already prepared, sterilized, and then we have added 99 ml of this culture broth in different set of test tubes. As you can see in this diagram, we have taken different test tubes, and inside the test tube we have added the culture media, which is previously it is autoclaved and it is previously been sterilized. Okay, so this is actually the tubes that consist of the culture media in the form of the broth. Okay, and in that culture media, 9 ml culture media we have already prepared. So in all the test tube we have to go for the addition of different concentration of the antibiotics. Okay, like here the concentration of antibiotic is less, then you are increasing the concentration, then you are increasing the concentration of antibiotic. Maybe it is 50 microgram, then it is 100 microgram, then it is 150 microgram, this is 200 microgram, and this is 250 microgram. So in that inoculum we have added the antibiotics. Okay, so two things we have already added. Number one is a pre-sterilized culture broth 9 ml, and 1 ml we have to go for the addition of the standard antibiotic solution right from the lower concentration to the higher concentration range. Okay, then what we have to do? We have to go for the addition of the inoculum, that is a test microorganism. So that microorganism will be added later. Okay. So again here the condition is almost similar as that of this one. In this also you are having three things. Number one is a culture broth that favors the growth of the microorganism. Okay. Microorganism is also available that will try to multiply in the presence of the culture broth. But the third thing is what? That is the antibiotic. Maybe it is a standard antibiotic or it is the test antibiotics that will try to inhibit the growth of the microorganism. Okay. But as you can see here, like in the first test tube, what is the condition? The concentration of the antibiotic is very less. Okay. So if the concentration of the antibiotic is very less, then what will happen? Less inhibition will be observed. And if the less inhibition is there, then definitely more number of bacteria will be grown. As you can see with the help of this black dot, I have designated that number of microorganism is more in test tube number 1. But as soon as you will go to the next test tube, then what you will find that the concentration of the antibiotic is increasing. And if the concentration of the antibiotic is increasing, then definitely the level of inhibition will also increase. And if the level of inhibition will increases, then definitely the number of microorganism will go on reducing. Okay. So if we will compare it, like if we try to replicate in terms of the turbidity, then what you will find that the test tube number 1 will show more turbidity. Okay. Whereas test tube number 2 will show the lesser turbidity as compared to that of the test tube number 1. Okay. So in this case, we have, like in case of the method A, we have to find out the zone of inhibition in millimeters. Whereas in case of method B, we have to find out the turbidity of each tube. Okay. So here again we have to plot a graph between the concentration, but in the y-axis it will not be zone of inhibition, but rather in this case it will be the turbidity. So by preparing the standard plot, we have to prepare a standard plot by using the concentration of the standard antibiotic in the x-axis and turbidity in the y-axis. Okay. Then with the help of this standard plot, again we have what we have to do. If we are having any test antibiotic is available and definitely we don't know the concentration of the test antibiotic, then what we have to do, we have to find out the turbidity of the test solution. Okay. So whatever the reading that we are getting, we have to put that reading in the y-axis, and again by extrapolating the graph, we can easily find out the concentration of the antibiotic. And if there is some effect of the antibiotic or the test antibiotic on the turbidity of the solution, then definitely we can say that the test solution is having the property to inhibit the microorganism. So either by using method A, that is the cup and plate method, we can go for the qualitative and quantitative estimation of the test antibiotic, because in that case if the zone of inhibition is available, it means your test solution is showing the inhibition. So qualitatively it is having the property to kill the microorganism or inhibit the microorganism, and by using this graphical method we can easily find out the concentration of that particular antibiotic. Similarly, by using method B, that is cervidometric method, again if the turbidity is reduced because of the presence of the test solution, then definitely we can say that the test solution is having the property to kill the microorganism or to inhibit the microorganism. And definitely by calculating again by the graphical method, we can calculate the concentration in which that particular test antibiotic is effective and showing the inhibition of the microorganism. Thank you.